Hi, I'm Craig Lurie, and I'm the CTO and co-founder of Keeper. This is our on-demand product tour. This video lasts about 30 minutes, and we think you'll learn a lot, so let's dive in. In 2018 alone, cybercriminals cost businesses over $450 billion. That's a huge number that may seem too abstract to matter to your business, but think about it. What would a data breach cost to your business? Would it be such a huge blow you cannot recover? A big reason so much is lost in data breaches is because they go undetected for so long. If you don't have the tools to help you find them in the moment they happen, you're begging to be breached if you haven't already. How are you monitoring for this now? Employee passwords and privileged account passwords are a major point of entry. Most employees have to keep up with their 50 or more passwords for all the parts of their jobs. Of course, they're going to go back to picking things that are easy to remember, but that also makes them easy to crack. Once in, a cyber thief can do massive damage in a very short time, all without you knowing until it's too late. This slide is great because it shows where your weaknesses are coming from. I hope this challenges your assumptions about your environment because really, no one is truly safe without the right tools and software to protect your business passwords. Just as one example, the recent breach against Citrix was pulled off using password spraying, in which the attacker simply brute force tested common passwords. If Keeper was deployed and the passwords were managed by strong policies, the attacker would not have been successful. In any size business, it only takes one weak password on just one device to cause irreparable harm to your business. Weak password security is the Trojan horse for cybercriminals to breach your business. Over 80% of all cyber breaches are due to weak password security. Because of this, any cybersecurity strategy and budget must start with password security. Securing your organization's passwords for all employees on every single device they use is essential. So what do you really want to start with? Understand that employee passwords are your biggest point of vulnerability. If you don't have a way to monitor what people are using for passwords, are they strong or weak? Are they being reused? Are they using the same password for your HR portal as they use for their Facebook? Then it's only a matter of time until you're breached and possibly held hostage. You need to know who the carriers of weak passwords are so you can go to them immediately and fix it. On the flip side, you need a solution to be easy to use. If your employees find the tools difficult or frustrating, they'll quit using them. If they do not adopt and use, you are right back to where you started. So you have to make sure the tools are friendly yet powerful, intuitive yet safe. This is where Keeper comes in. Our solution is chosen by enterprise customers over the competition for three main reasons. One is security. We are the most secure product with zero-knowledge architecture. Two, easy to use. With over 14 million users worldwide, we have a solution which is loved by users and can be easily deployed. Users on Keeper see the immediate lift in productivity by removing the pain of password resets. And three, ease of deployment. Our advanced provisioning methods give business and enterprise customers the ability to deploy Keeper with Active Directory, SSO, SCIM, and other methods, which is critical for adoption. With millions of users globally and over 7,000 enterprise customers across major industry verticals, such as financial services, banking, healthcare, government, and technology, we have the strongest solution and the experience to implement in any environment with high adoption among employees. You don't have to take my word for it. Check these top sites for ratings and reviews on our product. We didn't pay for these. We earned them through honest product reviews by our customers. This is what life looks like without Keeper. Unknown password strength and reuse. No auditing capabilities or visibility into password use. Excessive password reset help desk costs, weak SSO security, and password fatigue. With Keeper, you get best-in-class security, flexibility, ease of use, and a world-class support organization. This demo will show you how to prevent data breaches through our enterprise-grade, zero-knowledge password management and privileged account management cybersecurity platform. We'll review the end-user workflow, user provisioning, and advanced topics including the advanced reporting and alerts module for detection and remediation of password-related security events. First, let's talk about security. Keeper is a zero-knowledge platform. The data stored in a Keeper vault is encrypted and decrypted locally on the user's device using keys that are derived by the user's master password or auto-generated by our on-prem SSO key management software called Keeper SSO Connect. Keeper security employees have no ability to decrypt customer data because the keys are managed by the customer. In addition to zero-knowledge architecture, Keeper provides a number of two-factor authentication methods including Google Authenticator, Microsoft Authenticator, SMS, and FIDO U2F security keys. Keeper security is SOC 2 and ISO 27001 certified, and we actively maintain a public vulnerability disclosure program and bug bounty program with BugCrowd. For more information about our security, please visit our public security disclosure page at keepersecurity.com/security. Let's start off with the end user experience. Users can log into Keeper with an existing identity provider, such as ADFS, Okta, or G Suite, or you can log in using a master password. First, I'll show logging in with a master password. The master password is selected by the user and must adhere to the policies of password strength set by the admin. After a successful authentication, I'm prompted for two-factor authentication. In this case, I'm using a YubiKey device. Next, I'll show logging in with an identity provider, and in this case, Okta. I can access my vault by visiting the Enterprise SSO login screen, typing in the enterprise domain, and clicking Connect. After logging into my identity provider, my vault is decrypted. I can also just access the Keeper icon from my SSO dashboard. For example, in Okta, I simply click the Keeper icon. Here in my vault, users can store and protect passwords, documents, media files, and privileged account credentials such as SSH keys or API keys. Vault records can be viewed as tiles or as folders. Our password generator helps users generate strong and unique passwords for every site. Records can be created with custom fields and placed into private folders, subfolders, and shared folders through drag and drop. Users can also attach any type of file to Vault records, such as a passport photo, media file, SSH key, or any secure document types. Drag and drop makes it simple to quickly protect files in the Keeper record. Let me quickly describe how data is protected in a Keeper vault. After I've successfully authenticated, an encryption key is derived from my master password using PBKDF2. This key is used to decrypt another key called the data key. The data key is used to decrypt my individual record keys and shared folder keys. Record keys are used to decrypt the data within each record. Every record in my Keeper vault is protected with an individual client-side generated encryption key. Keeper encrypts all data with 256-bit AES. So if I have 1,000 records in my vault, then I have 1,000 256-bit AES keys protecting it. Keeper is a platform and device agnostic solution, so users can log into the vault across native applications on Windows, Mac, Linux, iOS, Android, and Surface devices. We're also fully integrated into all web browsers including Chrome, Safari, Firefox, Edge, and Internet Explorer. Keeper desktop software can be deployed to users through SCCM or direct download from our website. On devices that support biometric authentication, Keeper can log in without having to type in a password. iOS Face ID, Touch ID, Android Fingerprint, and Windows Hello platforms are supported. Admins can control the use of biometrics on approved devices. Encrypted ciphertext is stored locally on each device, and it's also synchronized through Keeper's Cloud Security Vault on Amazon AWS. If permitted by the Keeper administrator, users can log in and decrypt their vault when disconnected from the network, even on browsers and SSO-enabled accounts. On the Web Vault and desktop app, there's an offline mode indicator on the login screen and inside the vault. To activate this feature, click on the Remember Me checkbox when logging in. Role enforcement policies to restrict offline access will be covered later in this demo. When signing into Keeper for the first time, users are asked to import existing passwords that are stored in web browsers, spreadsheets, or other password managers. Keeper scans the user's web browsers for passwords that are unprotected and imports them into the vault. Users can also import passwords through a CSV file or another password manager like LastPass or KeePass. Step-by-step instructions are provided for each format. Keeper's autofill technology makes it easy to log in, save passwords, and change passwords on any website or application. Keeper locks appear in the login form fields and help the user log in with one click. Keeper seamlessly handles multiple accounts per site. For security reasons, Keeper will never autofill and log into a website without a user's permission. There are many options to configure within the browser extension. The settings screen of the Keeper fill here on the browser toolbar gives the user complete control over the workflow. This controls how Keeper prompts for login, filling, auto-submit, saving, and changing passwords. Keeper can also change passwords for you. Let's look at a site with a weak password and change it. This password change is synchronized to all of my devices in real time, and if it's shared to another user, it will also be updated inside of their vault. There are many use cases for shared passwords. For example, within an IT team, there are privileged account credentials, or within a marketing team, there are shared social media passwords. Keeper provides simple and secure tools for sharing individual passwords or an entire folder. Passwords can be shared with other individual users or with a team. The user can assign read-only, edit, and sharing permission. Here's an example of sharing privileged accounts among a team of engineers. I'll create a new shared folder called Database Passwords, add a MySQL database password, and then share it to the Linux admin team. The default folder permissions screen applies to new records or users who are added to the shared folder at a later time. By default, read-only permissions are applied. It's important to note that all of these sharing features can be restricted to certain roles within the organization, or sharing can be disabled completely. This is something the admin can customize through the Keeper admin console. The Keeper platform maintains a version history of every change made to every record in the vault, including password changes, custom fields, and file attachments. To access version history or to restore a previous version of a record, click on Options and then Record History. To view and restore deleted records, visit the Deleted screen. All of the Keeper end-user apps have the capability of switching between business and personal vaults from the login screen. We recommend that employees separate business and personal vaults due to the fact that the administrator may configure vault transfer policies. Any passwords stored in the personal vault will not be affected by the policies in the enterprise. If an employee leaves the company, they will be able to transition their personal vaults to a consumer license. We offer several secure add-on products that can integrate with the Keeper Vault. One of them is called Keeper Chat, and it's a secure messaging solution. With Keeper Chat, users can send and receive secure encrypted messages with other Keeper users in the organization. Messages, media files, and documents shared in Keeper Chat are fully protected within the vault, and they can be set to self-destruct. Keeper Chat supports team messaging, and it's integrated into the team management from the Keeper admin console. All of the information shared within Keeper Chat adheres to Keeper's zero-knowledge principles with client-side encryption and user-friendly features. Keeper Chat is available for Windows, Mac OS, iOS, and Android devices, and it integrates with the Password Vault for seamless login. Another secure add-on we offer is called BreachWatch. BreachWatch scans passwords in employees' vaults against public data breaches and the dark web. We use a secure zero-knowledge method of scanning passwords that alerts users in the vault if a password has appeared in a data breach. Users can take immediate action on these alerts by rotating the password on the target site. Admins can also be notified for privileged account password breaches within the Keeper admin console. The Keeper admin console is where your administrators will provision users, set role enforcement policies, manage teams, and audit the password and privileged account related security events of the organization. Here in the console on the left side are what we call nodes. A node can represent a different division, location, or business unit within the organization. Nodes can be nested, and each node can have different users, roles, teams, and administrators. Also, each node can provision users in different ways. Smaller organizations may not need to use separate nodes, and users can simply be added manually through the user interface or imported through a CSV file by clicking Add Users. The user will receive an email invite that they can click through and complete the setup of their vault. I'll now talk about more advanced provisioning and single sign-on integration methods. So if your organization doesn't use these systems, feel free to skip to the next section. The enterprise tier of our product provides onboarding capabilities described in this section. When using Active Directory, a node can be synchronized to an AD forest, and the management of users can be completely controlled through AD. Here's an example of that. This node tree called Engineering is provisioned through Active Directory. The Keeper Active Directory bridge software automatically provisions nodes, users, roles, and teams through a service which is installed on any domain-connected server, and it can be customized to sync designated users from AD to the Keeper admin console. Here's my server running my Active Directory environment and the Keeper Bridge software. There are three main tabs here in the Bridge software. On the Connections tab is where you authenticate to AD and the Keeper Cloud. For automated team creation and team encryption key distribution, the Keeper admin needs to authenticate via the admin login screen. On the LDAP AD tab is where the admin can customize their LDAP queries to filter out only certain nodes, roles, teams, and users. On the Options tab, there are several ways to customize the way that the AD bridge interfaces with Active Directory. For a full detailed user guide of the Keeper bridge, visit our documentation portal at docs.keeper.io. Nodes can also be provisioned through any SAML 2.0 identity provider, such as ADFS, Okta, or G Suite. Our SAML 2.0 integration is very popular with larger enterprise customers, and it's accomplished using our Keeper SSO Connect software. Keeper SSO Connect gives customers the ability to authenticate and provision users to their Keeper Vault on any device and any web browser without having to type in a master password. This is critical for organizations that require all enterprise applications to be integrated with an existing identity provider. The unique and powerful aspect of Keeper's SSO integration is that the software is hosted and managed by the customer on-premise or in the cloud. The reason we deploy the software in this way is to retain our zero-knowledge architecture. The encryption keys used to encrypt and decrypt the end-user vaults are generated and managed by SSO Connect and provided to the end user after a successful authentication. At the beginning of this demo, I showed how simple the login flow is for an SSO-enabled account. The user can click through from their SSO dashboard or sign in directly from Keeper by logging into their identity provider. Here's a system flow diagram showing how the users authenticate into their vault. The SSO Connect software is installed on the customer's hardware, and it can be optionally integrated with Gemalto HSM modules for another layer of key protection. Our business support team will assist in the integration and implementation of SSO into the customer's environment. In most cases, we can deploy with AD or SSO in just a matter of 1 to 2 hours. Here's my SSO Connect server running. We support both Windows and Linux environments. Once the service is installed, the admin can bring up the user interface. After logging in, the admin configure the port mappings, SSL certificates, and exchange metadata files with the identity provider. This can also be totally automated and scripted on the command line. Keeper SSO Connect operates in a full HA configuration for 100% uptime, and it scales to an unlimited number of users with minimal system requirements. Coming back to the admin console, one thing to note is that multiple provisioning methods can be stacked together. For example, it can provision users with Active Directory and then authenticate users with SSO. In that scenario, we recommend disabling the just-in-time provisioning feature within the SAML 2.0 configuration. A detailed step-by-step guide on installing and configuring Keeper SSO Connect is available on our documentation portal at docs.keeper.io. Having completely different provisioning methods across different nodes is a powerful capability of the Keeper admin console, and it's built to scale for large enterprise. In addition to Active Directory and SSO, we also support SCIM, API provisioning, and email auto-provisioning. To set up a new provisioning method, click on the Provisioning tab, and then click on Add Method. I'll explain a few more of the provisioning methods we support. We already reviewed AD and SSO methods. The next method here is called SCIM, which stands for System for Cross-Domain Identity Management. SCIM is supported in Microsoft Azure, Okta, G Suite, and many other identity systems. It takes just a few clicks to configure this option, and Keeper will then receive user, role, and team assignments automatically on the back end. Email auto-provisioning was created for large organizations that simply want their users to self-enroll with Keeper. Keeper validates ownership of the domain and only permits authorized users to create their vault accounts. When the user creates their vault, they're immediately added to the default role enforcement policy set up for that node. Many universities use this method to roll out Keeper to their entire student population. Last is the command line and API provisioning method. Keeper Commander is an open source SDK available on GitHub that gives administrators a command line interface or scriptable interface to Keeper. Keeper Commander can automate many different capabilities of the platform, including creation of user vaults, assignment of nodes, roles, and teams, importing and exporting of vault records, vault data management, running reports, and rotation of passwords through our plugin modules. Role enforcement policies control how users access privileged accounts and utilize the vault on their devices. Any number of role policies can be created and then applied to one or more users. The same user can be part of multiple roles, and they will receive the most restrictive, or in other words, the least permissive, settings across the policies. Role policies can also be assigned administrative permissions. We call this delegated administration. A role with delegated administration is able to log into the Keeper admin console to manage their node. Here, for example, let's look at the engineering manager role, which has admin permissions over the engineering node. Click on the configuration icon under Administrative Permissions to customize the permission required by this administrator. Let's create a new policy for a web developer. To create a new role enforcement policy, click on Add Role. Click on Enforcement Settings to construct a least privilege policy for this role. You can control the master password complexity, master password expiration, whether or not biometrics can be used to log in, for example Face ID, Touch ID, and Android fingerprint. We recommend that customers enforce the use of two-factor authentication to prevent unauthorized access to a user's vault if their master password becomes compromised. Keeper supports several 2FA methods including text message, TOTP apps like Google Authenticator, Microsoft Authenticator, Duo Security, and RSA Secure ID. Choices of 2FA methods can be limited to users based on the company's preferred methods. After a successful authentication and two-factor code verification, a device token is created which is stored locally on the device for subsequent API calls. The admin can customize exactly how long this device token is valid and therefore how often users will be prompted for a new two-factor code. This is controlled through the two-factor code duration setting. For example, users on their mobile device could be prompted one time, and users on a web app or desktop app could be prompted every login. In addition to the 2FA methods displayed here, all Keeper users are able to activate one or more FIDO-compliant hardware security keys, such as a YubiKey. The platform screen gives admins the ability to lock down this role to access the Keeper Vault only on specific device platforms. By default, users can access Keeper on the Web Vault, browser extensions, mobile devices, and desktop apps. This can be customized based on the security policies of the organization. The Vault Features screen controls the security features in the Vault like masking of fields and purging of deleted records. For example, the company probably doesn't want a user logging into the Vault, deleting everything, emptying the trash bin, and then quitting. This enforcement policy will prevent that scenario by ensuring a certain number of days has passed before a deleted record can be permanently deleted. Deleted items can also be purged after a certain number of days. On the sharing and uploading screen, admins can control whether or not this role is able to share records. Sharing can be completely restricted, or it can be restricted to certain users. Record sharing with file attachments can be restricted, as well as uploading attachments to records. Exporting of records from the web app and desktop app can also be restricted. On the Keeper Fill screen, admins can disable the browser extension for specific sites. For example, the company may have an internal application on the network that's not compatible with the extension. The Account Settings screen gives admins control over critical Vault security settings related to the physical endpoint where the Vault is deployed. By default, users can access their Keeper Vault while disconnected from the internet. The Restrict Offline Access enforcement will prevent users from accessing their Vault while offline or in airplane mode. It's important to note that Keeper never stores any clear text or unencrypted data on the user's device. All data is encrypted on the device using 256-bit AES. When the user logs into their Vault offline, the data is decrypted locally, and they're able to perform limited functionality. Admins can prevent users from changing their email, disable the automatic email invites, and also customize the logout timer setting based on platform. For example, company policies might dictate that the web and desktop applications must auto-log out after 30 minutes, and mobile devices must log out after 1 minute of inactivity. PBKDF2 iterations defaults to the maximum value of 100,000. IP whitelisting can be used to lock down access to the Vault for a particular role, such as an admin role, to certain IP or physical locations. For example, admins can require that users with delegated admin rights are only able to access Keeper from their internal network. The Transfer Account Permission is a critical role enforcement policy to handle employee termination or offboarding scenarios. Keeper supports the ability for a specific role to transfer a Vault from one user to another user. For example, in this case, I want the engineering manager to have the ability to log into the admin console and perform a Vault transfer of any user who has the web developer role policy assigned. The account transfer feature is a zero-knowledge operation that allows the Keeper administrator to create a hierarchy of transfer permissions within the system. For example, it can be organized such that the engineering manager Vault can be transferred by the C-level executives, but the C-level executives cannot have their Vault transferred. In order for a management role to appear in this list, the role must have administrative permissions configured for that role. Any user with the transfer account permission applied will receive a pop-up notice when they log into their Vault. After accepting the notice, their data key is encrypted with the public key of the role enforcement policy. When the admin performs a Vault transfer, a one-directional encryption operation is performed where the admin is able to decrypt the source user's Vault, re-encrypt the data with the destination user's public key, and then transfers the ownership of the vault records to the destination user. The important thing to note from a security perspective here is that the admin is never able to simply browse a user's vault or become that user. Once a vault transfer has occurred, notifications are sent to the users and the source account is deleted from the system. Teams are specifically used for shared folders. At the team level, you can enforce certain restrictions like being able to prevent password viewing, disabling record edits, and disabling record reshares. Teams can be added to shared folders from the vault. Here, I've shared a folder called Shared Financial Records with the Bank Access team added. Teams can be created by simply clicking Add Team. For enterprise customers, teams can automatically be created through several provisioning methods, including our Active Directory sync, SCIM, and Commander SDK. The Security Audit section of the console gives admins the ability to monitor the overall password strength and security score of the organization. Since the Keeper platform is zero knowledge, our encryption model prevents an admin from simply decrypting and viewing any user's vault. This critical architecture prevents rogue admins from accessing the data of employees at all levels. Summary statistics are gathered by the client devices and shared with the admin for an overall score, so the admin can take action and enforce internal policies. Some of these scores can be forced to 100% based on role enforcement policies. For example, strong master password strength and two-factor authentication can be enforced for all users. The admin can drill into the score to see user-specific details. For example, we'll look at the Record Password Strength report. This report describes which users are properly using the password generator and storing passwords for all their records. If a user is storing weak passwords, action can be taken by enforcing stronger policies or communicating with the employee for training. The Advanced Reporting and Alerts module is an extremely powerful module that tracks over 80 security events across the organization and addresses many password-related cybersecurity auditing, alerting, and compliance needs. This module provides insight to assess vulnerabilities related to password reuse, password access from unauthorized users, password stuffing attacks, and insider threats. The reporting dashboard view provides a quick view of top events, the recent activity report, and saved custom reports. Monitoring these events can assist in the detection of several threat vectors and help establish enforcement policies around vault access and privileged account access. Drilling down into the timeline chart, we can see the last 30 days of event activity within the system, grouped by event type. This can help to identify anomalies and usage patterns. Going back to the recent activity report, we can see a full log of all event history that has occurred within the platform. Filters can be customized on users, event types, event attributes, and date range. Data can also be exported for offline analysis. The custom reporting capabilities are extremely powerful for auditing the usage of the platform and performing forensic analysis. For example, let's create a custom report that focuses on security-related events. Here in the event data, this shows the admin that a user was just given administrative permission. It's highlighted in red. Within each event, the event details can be expanded. In this particular event, we can see which user generated the event, where it occurred, exact IP address, and the date and time. Event reports can also be generated on team shared folders or privileged account passwords within the platform. Here's a report showing all events related to a shared folder called Network Admins. Here there's an event that took place at 2:38:59 p.m. where a team was added to this shared folder from the web app. To track critical security events, alerts can be created. Admins can create an unlimited number of alerts that trigger on over 80 different event types and attributes. For example, here's an alert that is triggered upon any policy change event within the admin console. I have this alert configured with 12 different event types which fall into the category of policy change. The user who generated the event will receive the alert, and also I have it configured to send me a text message on every event occurrence. Event alerts can also be triggered on a particular attribute, such as a record UID or a shared folder UID. For example, if I want to be alerted anytime a Twilio password is updated or autofilled on a web form, this can be quickly built. In addition to the reporting and alerting capability we offer through the admin console, event data can be streamed into any existing SIEM solution such as Sumo Logic, Splunk, Amazon AWS, or any other syslog-compatible destination. This can be configured on the external logging screen. Once configured, our system will automatically push all event data to the customer's SIM. Here's a screenshot of a Sumo Logic installation that is integrated with Keeper. Reports can also be generated automatically on Keeper Commander, our open source command line and SDK toolkit. For enterprise customers who require automated password rotation of privileged account passwords, our Commander tools provide this capability. Keeper Commander plugins are available for the most common systems, including Unix passwords, SSH keys, Windows passwords, Active Directory, Oracle, MySQL, and more. Custom plugins can also be developed with a few lines of Python code. The last thing I'll touch on for this demo is our personalization features. Customers can add their organization's logo so it appears on the vault for end users. The email invitation that users receive can also be customized to include corporate branding or other special instructions. This wraps up our demo of the Keeper Business and Enterprise platform. Thank you.